Okay, so now let us get to section 5.2. We are talking about the definite integral now. So in section 5.1, we work with the Riemann sum, right? The left, the right, the left, and the midpoint, okay, to approximate the area under the curve, under the graph, right? By rectangles of equal width and the height of the rectangle are the values of f of x at the endpoint or the midpoints of the subintervals. Okay, so in these sections, we would like to find kind of like a general case. Okay, so to specify this Riemann sum, we choose a partitions and a set of sample points. Okay, the partition is we are going to separate this into n subinterval with the equal width, okay, delta x. And then now you will see that the partition basically is x equal to a naught, and then x sub 1, x sub 2, up to x sub n, okay, is equal to b. And then those subintervals is x naught, x1, x1, x2, and so on and so forth. And then what is the sample points? Now, sample points basically is any point, okay, in between the subinterval. You could choose any point, and then we make it x of 1, okay? So once you choose the point, then this height right here, for example, it will be f of x of 1 star then, okay? Then the area of this rectangle right here, it will be f sub x1 star times delta x. And then now, this is exactly what happened. Then we could create all the rectangle then, okay, to approximate the area. Okay. Then you will see that the general Riemann sum, okay, now again, this is the area of each rectangle, and then we add them up, right? Then you will see that the total area we make n to infinity. To make n go to, it's not 0, right? It's go to infinity. Then what happened here? As n go to infinity, then what happened to delta x? Delta x go to 0 then. Of the Riemann sum, okay? Then this is the idea about the definite integral. Again, this is n go to infinity, okay? So this limit is the definite integral of f from a to b, which we write into this form. So then let us look at this form right here. Now remember, this whole thing is one symbol. So you could not just write the integral from a to b of f of x without the dx, okay? It must be the whole thing. And then this symbol right here is the integral sign, okay? Now basically this integral sign right here is kind of like an S, and then we stretch it, okay? Then it become like this, okay? It's just kind of like the sum, right? The function f is what we call the integrand. The number a and b is the limit of the integrations. A is the lower limit, and b is the upper limit then. And dx simply indicate that the independent variable is x, okay? So for example, if we want to evaluate f of t from a to b, then in this case, we will have dt then, okay? And the procedures of calculating an integral is called integrations, okay? Okay, so now let us learn what does this mean by the definite integral then. Draw a graph of the sign area represented by the integral and compute it using geometry then. Okay. So first of all, you have to know that this 4 right here is mean that I have a function f of x is equal to 4. This is actually my integrand, right here now. Okay. So this is x, this is y. Okay. And then in this case, basically I have f of x is equal to 4 here. Okay. And then what I would like to do is actually is, in this case right here, my lower limit is -2 and my upper limit is equal to 1. Okay. So what we are looking for here is, actually we are looking for the area in between -2, x equal to -2 and x equal to 1, right? And then under the function f of x equal to 4. So therefore, in this case, my answer will be 4 times 3, right? 4 is the height, and then 3 is just the width then. So therefore, in this case, my answer will be 12 then. Okay, so this is exactly the idea about the definite integral, okay, if the function is positive. Okay, okay, so now it is your turn. Now go ahead and try to work on B now. Okay. Okay, so now again, my integrand is 2x, okay, meaning the function, okay, f of x equal to 2x, right? Then, of course, okay, so this is f of x equal to 2x. And then what we are looking for, we are looking for the area, okay, is between 0, my lower limit, and my upper limit is 4. Then we are looking for the area here now. Okay. Again, if we are talking about the positive sign. Then now, we know that when x is 4, then this y value is 8, right? So this is 8 right here. And then this is 4. So therefore, the area basically is 1/2 base times height. Then my answer is 16 then. Yeah. Okay. So now this is actually is when we want to find the area and also if the function is positive. Let us look at the general case of the definite integral then. Geometric interpretations of the definite integrals has assigned areas. Okay. In this case right here, if the function is about the x-axis, then this, of course, we could consider that this is actually a positive area. However, what if the function is below the x-axis? Then in this case right here, okay, so again, we could still consider the area, but in this case right here, we have a negative, okay. So then this is actually is what happened here. So therefore, when we try to integrate from a to b of f of x dx equal to sine area of the regions between the graph and the x-axis over a and b. The area above the x-axis subtract the area below the x-axis. Okay. So if you understand this, then let us try to work on number 3 to see if you understand the idea here. Okay. Okay. So right now to this one, I would like to take the integrations, the definite integral between 0 and a of f of x dx. Okay. So in this case, meaning, okay, if we look at the graph, basically what we are looking for This is 0, this is A right here. We look at this area right here, right? And then from this graph, I know that the area is equal to 16. So my answer will be 16 then. Okay, then now let us look at B. We would like to integrate from 0 to B. Okay, then let's check this out. So the function is here to A, and this is B right here. Okay, so then in this case, I have this area. But remember, we need to subtract this area. Okay. So therefore, in this case, I will have 16 minus 5 then. And my answer will be 11. Okay. Okay, now it is your turn. Now go ahead and try C and D. Okay. So remember to this one right here, I would like to do it from A to C. So in this case, I will have -5 plus 11. Right? Okay, and the last one is from 0 to C. Then I will have 16 minus 5 plus 11. This is 22. Okay. Okay, so then the next problem, number 4. Again, please pause the video, try to finish the 2 problem A and B. Okay, and then we could actually check out the solution. Now remember, this 2 right here is actually the semicircle, right? Okay, so then let us look at A now. Okay, so to this A, I will have 1, 2, 3, and 4. Okay, so then between 1 and 2, and this is 3 and 4, right? So I have this area, and this is another area. So therefore, in this case right here, okay, now we know that the R in this case is 1. So is I will have pi R square over 4, because it's only a quarter. And then we add to, in this case, R is 2, pi 2 square over 4. Then it will be negative pi over 4 plus pi. So as my answer will be 3 pi over 4 then. Okay, now and then now to B is actually we need to work with a absolute value of the functions. Now remember, to the absolute value basically is all the negative input, or maybe I should say that all the negative outputs become positive output then, right? So I will have 1, 2, 3, 4, 5, and 6. Okay. Then in this case, the graph basically is like this. And this then. Okay. And now this function right here, it will be the absolute value of f of x then. Okay. So what we are looking for is we are looking for those area now. So it will be, again, pi r square over 2 plus pi 2 square over 2. Then I have pi over 4. Oh. Oh, my bad. Because we are looking for from 1 to 6, right? I need to be careful about the lower limit. Okay, so then it will be over 4 here. Then I have pi over 4 plus 4 pi over 2, so it's pi over 2 pi over 2 pi then. Then of course, my answer will be 9 pi over 4 now. So again, if it's open 1, then we multiply top and bottom by 4, right? Okay. Okay, so then let us work on more problems here. Okay. Now, the next 3 problems, what we need to do is we just need to sketch the function and then try to work out the problem then, okay? Okay. So to this function right here, okay, y-intercept is 7, and then I have the slope is going down. So basically, I know that this point right here, it will be 7, okay? And then what we are looking for is, we are looking for in between 6 and 8. Okay. Actually, if you notice, okay, these 2 areas, they're the same, and one is positive, one is negative. That means my answer will be 0 then. Okay. If I have an absolute value of x, okay, and then I would like to have it between -2 and 3. Okay. So, of course, we know that this height right here, it will be 2, this is 2, and then here, it will be 3, this is 3, okay? So it will be 1/2 2 times 2 plus 1/2 3 times 3 then. Yeah. So I will have 2 plus 9 over 2. So it's 13 over 2. Okay, so if we do the transformation to this one right here, we are moving the absolute value of x to the left by 1 unit then. So this is one right here. Then I would like to so I would like to do it between -2, 3. Okay. So it will be here and here. Okay, so to this one, we know that this height right here is 1. this is 1. Then, of course, from here to here is 4. Then this is also 4. Okay. Again, when x is equal to 3, then 3 plus 1 is 4, right? Then now we will have this is 1/2 1 times 1 plus 1/2 4 times 4. So I have 1/2 plus 16, half of 16 is 8. So then this would be 17/2 or 8.5. So right now, let us look at some properties that we just learned. Okay. Now you will see that let f and g be integrable functions on the interval that contain a, b, and c. Okay. So if we want to find, okay, so in this case right here, I actually have a function f right here. Then you will see that if I integrate from a to a, in this case right here, we have no area, right? So therefore the answer is equal to 0. And then if we want to integrate it from b to a of f of x dx, it is the same thing as we integrate it from a to b of f of x dx, but with the negative sign. Because we interchange a and b. And then to this one right here, if we integrate from a to b of f of x plus g of x, in this case, we could actually separate that. Okay. And then add them together. If we have a constant multiplied to a functions, in this case, we could take out the constant. Okay. Now, you will see that number 3 and number 4, you could consider that it's just like a summation, right? So remember, if we add, if we sum f and g, we could actually separate them. Okay. And then to C, to number 4, if we multiply a constant, we could take out a constant. Okay. And then the last one here, if we integrate between a and b of f of x dx, and c is in between, then we could actually, you could consider something like this. So we have a and b, we integrate between here, and then c is any number in between. So if we integrate between a and b, this is the same thing. We integrate from a to c and from c to b, right? And then we add them together. Okay. So the function absolute value of f is integrable on a, b, and the integration a, b, integration of the absolute value of f of x dx is just the sum of the area of the region bounded by the graph of f and the x-axis. So to this one right here, the number 6, you could actually look at the example, this one right here, right? Okay, so now let's see how could we use, okay, the table right here to help us to work with the problem number 8 then. So right now, what do I know? I know that the integration of from 0 to 5 of f of x dx is equal to 5, and integrate 0 to 5 g of x dx is equal to 12. Okay. So then, of course, to this one right here, what we could do is we could use a property number 3, right? So it will be here, f of x dx. Now remember, don't forget the x, right? It's because this whole thing is one symbol, plus 0 to 5 g of x dx. Then of course, in this case, I will have 5 plus 12, and the answer is 17 then. Okay, now then right now try to work on B. And then to this one, 2 is a constant, so we take it out of the equations. And same thing with 1/3. And then now we could do the math now. 2 times 5 minus 1/3 times 12. And it will be 10 minus 4. So your answer is 6. Okay, so after we warm up with number 8, well, then let's try number 9 and number 10. Okay, so to number 9, we would like to work with integrate from 4 to 1 of f of x dx. Then, of course, to this one, we could actually work with number 2 right here. So it is negative of 1 to 4 f of x dx. So I will have negative 7 again. Okay. Okay. So how about if I want to integrate between 1 and 2 of f of x dx? Then you will see that here, what we could do here is, okay, so again, maybe let me draw a function f right here. Okay, and this is 0, 1, 2. Okay, so right now, what I'm looking for the area between 1 and 2. Okay, so what we could do here is probably we could find the total area, okay, between 0 and 2 first, and then subtract the 0 and 1, right? Okay, yeah, this is exactly what I'm going to do here. So I will have from 0 to 2 f of x dx minus 0 to 1 f of x dx. Then in this case, I will have this is 4 minus 1. So the answer is 3. Okay. Then the last one here, I would like to express, okay, the integral has a single integral. Okay. So what does this mean? It means that I would like to equal to have a different lower limit and the upper limit of f of x dx. Okay, then let's see what is going on. So first of all, I have it is from 2 to 9. Okay, so this is what we have. And then now, what do? We would like to subtract from 4 to 9. And remember, this is 2 right here. Then, if you look at this, what do you get? Your answer is actually from 2 to 4, right? So, meaning what the answer that I have, I should have it from 2 to 4 of f of x dx. Okay. So now, let's see. How do we actually work it out? Okay, kind of like algebraically then. Now, this is actually my answer already. But again, let's see how do we actually do the math now. Okay. Then what I'm going to do here is, okay, right now, what I'm going to have is, now, I would like to work with this one right here. So we know that if is I want to integrate from 2 to 9, then what I could do is I could make it become 2 to 4 f of x dx plus 4 to 9 f of x dx, right? Okay. This is what I have. And then what I'm going to do here is I would like to subtract from 4 to 9 f of x dx. Okay. Now you will see that this part right here is actually is I'm using this number 5 right here to help me to do. Okay. And of course, you will see that the result that we have, it will be, we got these two to cancel, right? Then I will have it from 2 to 4 of f of x dx. Okay, so this is exactly what we know about the problem. Okay. Okay, so then that is it for this section right here. Okay. Okay, thank you.